Hey there, Sixes. So today I want to introduce an idea of spread. I should just read through this. The idea of spread we're going to introduce is mean absolute deviation, or MAD, MAD. Um, so you guys already know measures of center. You know mean, median, and mode really well. That's great. You've also seen that data sets have similar centers, but can still be very different. So you saw this, the best example was yesterday with New York versus San Francisco data, where you saw that New York had much more spread out temperatures. The averages were almost identical, but San Francisco was clustered near the center and New York was really spread out, so it gets super cold and super hot. Today we'll learn a good way to measure that spread, because the fact that we can describe these centers really well, but we can't describe how they're spread out is a problem. So today we'll learn one good way to measure it. But first we need to talk about deviation, and this makes sense. If we're talking about mean absolute deviation, first we're going to find the deviation, and then we're going to find the mean of those deviations. We're going to average the deviation. So let's look at what this means. And to do it, I want to ask the question, according to this data here, are boys faster at solving a puzzle? So can that data support that? Well, here's some data showing how long in minutes it took boys and girls, boys at the top line, girls at the bottom line, to solve a puzzle. Are the boys faster? Well, if we calculate the means, then the boys, I know I just add up all the data points, I divide by 10, and when I do that, I get 35.3 as an average for how long it took the boys. I'll give you a minute. It shouldn't take you that long. Go ahead and pause the video and find out how long it took the girls on average to complete the puzzle. All right, I'm assuming you have a mean for the girls and the boys. And so when we go on, we'd see they each have their own means, and the girls on average solve the puzzle 4 minutes slower, or 4.1 minutes. So I said that here. On average, the boys solve the puzzle 4.1 minutes faster. However, here's the question. Is this true about the population of people, that the boys solve the puzzle faster than the girls do? So the girls, it's not just that these data points were chosen, it's the fact that the population of boys is faster, population of girls is slower. That is a possibility. Or is this a result of sampling variability? Here's the other possibility. Girls and boys are both under the same population, but the boys sample, we just happen to choose these red dots that are further to the left or faster. And the girls, we happen to choose the blue dots to the right that are slower. So that would mean that the average should be the same according to the population, but the samples we chose produced problems. They produced variation problems. And the real problem is we could make assumptions like the boys are faster here, and maybe it's false. Maybe our problem is sampling. So this measure of spread is going to be a way that we can use to test sampling variability eventually. Good, let's go on. So this is the question. Do we have different populations based on this data, or do we have one population with sampling problems or sampling variability? Mean absolute deviation can be super helpful for us to answer that question. The mean absolute deviation is the average distance from the mean. So to calculate it, first we need to calculate the mean. Well, that makes sense because we need to know that mean to know the distance from the mean. Then we have to calculate the distance of each point from the mean. So if we have 10 points, there will be 10 distances for how far those points are from the mean. This is each point's deviation. So that's what you're finding is that deviation. And then third, we calculate the average of the distances, or we average the deviation. We find the mean of the absolute deviation of each point. On the next page, let's look at it for the boys' data. So we have boys and girls data. We've already calculated the mean. We know it's 35.3 minutes. Find each point's deviation. So here's what I'm doing. I'm looking at 39 minus that mean of 35.3. Then in the next one, I'm going 38 minus 35.3 to find out how far that 38 is from the average. The next one, though, 27, I did 35.3 minus 27 because I just want to know how far away they are. So I want my answers to be positive. You could do 27 minus 35.3 and then take the absolute value or just make it positive, and that would be fine. And then when I go on, 36 here was 36 minus 35.3, so it's 0.7 minutes away. So the columns here, this and this, are my deviations. And so I take those and I average those deviations. And what we found there is that the average of the deviations is 4, like just about 4.04. So that means the average boy, the mean, is 35.3, And then the spread is 4. So how do we use that? Here's how. The means here are all in blue, and the deviations, or the spread, are all in red. So the mean shows the center. The mean absolute deviation shows the spread. So the average boy completed the puzzle in 35.3 minutes. That's the mean. But most boys, that's only the average boy, the most average boy. Most people don't end exactly on the mean. It's just the most average person does. So most boys finished in between the mean plus the main absolute deviation and the mean minus the absolute deviation. So mean plus the spread, I get 39.3 minutes. And mean minus deviation or spread, I get 31.26 minutes. So most boys finished not right at 35.3 minutes. Most boys finished between 39.34 and 31.26 minutes. And if we look at that, like 31, which ones would we have to throw out? Which ones are less than 31 or greater than 39? This one. This one. Do we have any that are below 31? This one and this one. So you'd see 6 out of the 10 boys were within this range. And then 4 of them were outside of the range. So most of the boys solved within that range. The same would be true for the girls. And we can use the same metric to test. Like, are we looking at this situation where the population is different or this situation where the sampling is different? And we can attack that question and solve it. We actually will, but it'll be later on. So for now, you guys have an assignment. I think you'll be able to get through this pretty quickly with the context of having done yesterday's assignment comparing New York and San Francisco temperatures. Now we just have a whole bunch of different cities. They all have the same averages, and you have to go and answer questions about them. And then we're going to walk you through creating that mean absolute deviation. If you have trouble with it, come back and revisit this video because it's the exact same ideas. You find the distance from the mean, and then I see this has direction, so 10 to the left or 3 to the right, whatever. That makes sense. So they're talking about deviation, and then they'll finish up mean absolute deviation. You'll actually calculate it. Best of luck, sixes. I'll talk to you soon. Bye-bye.